In this video, we will learn about flame tests, how to do them, why they work, and how they allow us to identify the metal ions in some substances. We'll look at the colours produced by alkali, alkaline earth, and other metal ions. A flame test is an experiment where a substance is put into a flame. Some substances give the flame colour. Understanding which substances produce which colours can help us identify unknown substances. Many substances will burn in a flame, producing red, yellow, white or blue hot flames, depending on the temperature. For a flame test, the colour is pretty consistent across the temperature range. For a flame test, the key factor is the heating, not the burning. Only some substances will generate visible light when heated in a flame. If a substance does produce a visible flame colour, that colour will be unique, although sometimes it is difficult to tell the difference. Let's have a look at how to do a flame test. There are many ways to do a flame test, but one of the simplest is the use of a platinum loop. A loop of platinum wire is very unreactive and does not colour the flame. In the first step, the loop is repeatedly cleaned with hydrochloric acid and put in the flame until all contaminants are removed. It's easy to tell when this has happened because putting a clean loop in the flame will not change the colour of the flame. The loop is then dipped in a test substance, either a solution or a powder perhaps, and put into the flame. If the flame colour changes, the colour is recorded. You could write down a description or take a picture. It is important that the flame is hot and does not produce a strong colour itself. If using a Bunsen burner, it is best to use a blue roaring flame rather than a bright yellow safety flame, so that the colour from the ions is easier to distinguish. To achieve a roaring flame, we just open the air inlet at the base of the Bunsen burner. Now let's look at what a flame test might look like for a common substance like lithium. When a substance containing lithium ions is put into a flame, the lithium ions emit visible light, turning the flame red. A lithium ion, Li+, has the electron configuration of 2 or 1s2. When heated in a flame, the electrons are excited, jumping to higher energy levels. When electrons fall back down, they can emit photons of light. The bigger the gap, the higher the energy of the photon, and the smaller its wavelength. The colour we see can be the result of many different wavelengths of light being emitted at the same time, but the wavelengths of light are unique to each element, so the colour we see is unique as well. That's not to say that the descriptions of the colours are always unique. Here's a table of ions and the colours of flame they tend to produce, along with a common description of the colour. The colours given are approximate. As you can see, there are some ions which produce very similar colours. Lithium and strontium deliver a similar red. Sodium and calcium both produce an orangey colour. Barium, boron and copper produce greens. And potassium, rubidium and cesium all produce purples. Telling these apart can be difficult, so other chemical tests might be needed, or a diffraction grating or spectrometer can be used to analyse the light in more detail. Some ions tend to produce more light than others. Potassium ions, for instance, produce a pale flame, while sodium ions produce a much stronger colour. If a sample is contaminated, the colour from one ion may overpower that from another, so it is best to do flame tests with very pure substances. Sodium is quite a common contaminant. Filters like blue cobalt glass, which is glass with added cobalt compounds, can be used to remove the bright orange-yellow light from sodium ions, allowing other colours to be seen more clearly. If you had a mixture of sodium and potassium ions, you could use cobalt glass just to visualize the colors from the potassium. Now that we know what a flame test is and how to perform one, and which ions it can help us identify, let's have some practice. In which of the following images does the result of the flame test indicate the presence of barium? In a flame test, we're adding an ionic solid, a powder perhaps, to a flame, and we're looking at the colour change. Each colour is characteristic of certain ions. A is a red flame, B is an orange or yellow, C is green, D is blue, and E is purple. To answer this question, we're going to need to recall what flame colour is characteristic of the barium 2+ ion. A green flame is indicative of barium 2+, boron 3+, or copper 2+. So we can be pretty sure that the green flame is the one most likely to indicate the presence of barium. A red flame is associated with lithium plus or strontium 2+. An orange or yellow flame is indicative of sodium plus or calcium 2+. A blue flame like this is most likely indicative of copper plus, while a purple flame, depending on the depth of its colour, is more likely to indicate potassium plus, rubidium plus, or cesium plus. So, of the images given, the one that indicates the presence of barium is flame C, the one with the green flame. Now that we've looked at a visual example, let's look at one that requires more memory. Which alkaline earth metal most resembles copper when analysed using a flame test? A flame test produces a colour depending on the ion. The alkaline earth metals are otherwise known as Group 2 on the periodic table. The elements in Group 2 are beryllium, magnesium, calcium, strontium, barium, and radium. Radium is rare and radioactive, so for the purposes of this question, we can ignore it. Each of these elements tends to form ions with a 2+ charge. To answer this question, we need to recall what colour flame copper produces in a flame test and compare it to those of beryllium, magnesium, calcium, strontium, and barium. Depending on the compound of copper, will produce a blue-green flame. Beryllium and magnesium have no characteristic flame test colour. Calcium ions turn flames orange-red. Strontium ions turn them bright red, and the flame test colour for barium ions is green. The closest colour of these to blue-green is the green of barium. So the alkaline earth metal, whose flame test colour most resembles that of copper, is barium. That's two examples where we looked at particular colours of flame. Now let's have a look at the practical aspect. A student uses a flame test to determine whether the major product of a reaction is a potassium salt. Which of the following would not improve the quality of the test? A. Closing the inlet of the Bunsen burner. B. Dissolving the product in hydrochloric acid. C. Viewing the flame through cobalt glass. D. Washing the sample loop in hydrochloric acid before use. Or E. Recrystallizing the product. A flame test is a way of checking for the presence of certain ions by the production of a particular colour of flame. A potassium salt will contain potassium plus ions. The addition of potassium salts to a roaring blue Bunsen flame will turn it a pale pink. If, when the student does the test, the flame colour is pink, then there's definitely potassium present. However, if the flame colour is not pink, it's not necessarily clear whether potassium is there or not. Our job is to look at the statements and see which one would not improve the quality of the test. A better quality test is more likely to produce a positive result. What about closing the inlet of the Bunsen burner? If the air inlet of a Bunsen burner is open, more oxygen gets to the flame. It gets hotter and it becomes more blue. If you close the inlet of a Bunsen burner, you'll produce a safety flame, which is a bright yellow. A bright yellow flame is likely to mask the pink of any potassium. So closing the inlet of the Bunsen burner would definitely not improve the quality of the test. Let's have a look at the other options just to be safe. Dissolving the product in hydrochloric acid first will make the solid easier to vaporize. In solution, the ions are already separated, so when they're heated up, they'll all go into the air and start emitting light. Depending on the concentration, there's an opportunity to vastly increase the brightness of the pink colour and improve the quality of the test. So this is not a correct answer. What about viewing the flame through cobalt glass? Cobalt glass is a blue filter. Viewing the flame through cobalt glass will remove the orange-yellow bright light from sodium. This will allow the pink colour from potassium ions to come through more clearly, improving the quality of the test. Sodium ions are quite common contaminants, so this is likely to be a good idea. Washing the sample loop in hydrochloric acid is another way of improving the quality of the test. Washing the loop removes other contaminants which might colour the flame differently and lead to an ambiguous result. Finally, we have recrystallizing the product. Recrystallization will purify the product. A more concentrated product means fewer contaminants that are likely to interfere with the results of the test. So recrystallizing the product is a good way of improving the quality of the test and therefore is not our answer. So of the 5 options given, a student doing a flame test to check if potassium is present in the product should probably not close the inlet of the Bunsen burner in order to improve the quality of the test. Now that we've looked at a few examples, let's wrap up. In this video, we've learnt that substances produce light when put in a flame. Some of these substances produce visible light with a distinctive colour due to the specific electron transitions. And the distinctive colours can be used to help identify specific ions in substances.